All right, so here's a problem where it's a little more complicated because we have this function here, and it's not in kind of vertex form, and there's a lot going on, right? But we can't exactly tell what the transformation is because it's in standard form, so you can't explicitly see. You can see that the y-intercept is 7, and so it kind of looks like it moved up 7, but that doesn't exactly translate directly to the vertical shift and things like that because you have this 8x in the middle. It's not exactly a direct change to the parent function, right? Because not only did we add 7, but we also added 8x, which has a variable in it. So it's a little different than what we just did before. We were able to just kind of see what it was from the original. So this, when it's in standard form like this, it's a little harder to use your transformations to graph it. So I'll show you a couple different ways, okay? So first of all, remember that this is A, B, and C when you have standard form. Whatever's in front of x squared is your A, whatever's in front of x is your B, and whatever your constant is C. Okay, so again, this tells you your y-intercept, right? So C is your y-intercept. All right, and then A and B we'll actually use to find our vertex, and we'll go from there. Okay. All right, so I want you to write this down in your notes as that C is the y-intercept, like we said, and then this is called the vertex formula, and this is a way to find the vertex without getting it to vertex form. So this is one way to do it, and this is maybe the more efficient way. I'll show you how to get it to vertex form, and you can decide which one works better for you. There's definitely benefits to getting to vertex form sometimes, but there's also benefits to using this sometimes as well. So this is the vertex formula, and again, well, not again, but H and K are the vertex, right? Remember that H and K are the coordinates for your vertex. And so the way that you find H and K are to use B and A. So H is negative B over 2A. So if you find what B is and you find what A is, you put them into this formula and that'll give you H. And then to find K, you just input whatever you get for H, right? Whatever this comes out to be, you put it in there into f of x. So you put it in as the input into this function, and whatever the output is, that is what your k value is going to be, the y value of vertex, right? If you know the x, you plug it in, and that'll help you find the y, right? That's what this is saying right here. Okay. All right. So let's do that with this one. So we know the y-intercept 7. So right away we can plot a point at 7. So 1, 2, 3, 4, 5, 6, 7. So we can plot a point here. If we wanted to, we could say that the y-intercept is actually going to be 0, comma 7, right? If x is 0, y is 7. So if we want to put a coordinate there, we can do that. For h, let's find that out. So negative b, so remember 8 is b, so that negative is built in. So you always start with the negative. We put in the 8, right? And then over 2 times a, and a is 2. So it's going to be 2 times 2. So I just put a 2 in there for a, 8 in there for b. And then if we plug this into our calculator, work it out, we get negative 8 over 4. And that turns out to be negative 2, right? So that's the x value of our vertex. So once we know this value, now we plug that in as our input, right? So now we're going to find f of negative 2, okay? And so we're going to plug 2 in for x there, right? So it's going to be 2 times negative 2 squared plus 8 times negative 2 plus 7, right? So I'm just putting 2 in for all these places, negative 2 in, excuse me, for all those places we have an x, right? Okay. And just to clear up, this is a plus sign here. All right. And so now we can work this out. And you don't have to show all the work for doing this. You can do this in your head, on paper, in your calculator. Any of those ways work. But remember to square it. When you square negative 2, you get positive 4. So that'll be 8. 2 times 4, right? So that'll be 8. And then here we get negative 16. And then plus 7. And so if we combine all that together, we get negative 1. Okay. So k equals negative 1, right? All right. And so those are the coordinates of our vertex. So our vertex in this situation is going to be -2, -1, right? So -2, -1, -2 on the x-axis, -1 on the y, so that ends up being right here is our vertex, okay? All right. So now remember, if that's our vertex, that means our axis of symmetry is what? Remember, it's always x equals h, right? So think about what h is, and you're just going to make x equals that. So x equals, okay, and if you put x equals -2, that's perfect. Remember, the axis of symmetry is always an equation, right? And so if we wanted to plot that or graph that, I'll put it in purple here. That will go like this. The nice thing about knowing the axis of symmetry now is we have this y-intercept over here, right here. And so now we can mirror that across the axis of symmetry, right? So it's going to go right here is the mirror of that, okay? And then now we have a couple points that we know it's going to be a parabola, so it's going to be something like that, right? And then the same thing on the other side. So that's the nice thing about axis of symmetry is if you get the y-intercept, and it's as long as the y-intercept's not the same as the vertex, then you'll have 2 points when you get the vertex and the y-intercept, and then you can use the axis of symmetry to find one other point and kind of get a real quick rough shape of what the parabola is going to look like. Okay. All right. So remember the vertex formula. That's one way to find the vertex, and that'll come in. That'll be helpful in a lot of cases.